Hey, hey. Okay, Yuri ist hier. Alicia is here. All right, so if you come, hi, Errol. As you come into the room, please say hi. Hi, Saskia, that we know you're here. Hi, Vicky. Good morning, Sadie. Yeet tea, top of the morning. Hallo, Charlotte. Who's Yeet tea? Charlotte Clara. Okay. Stefan Hagen. Okay. There we go. Sophie is here. Richard. Yeah. Now I remember. Okay. Yes, Richard. Hi, Richard. Okay. Carlos. Here. Darth Vader's sake. That's Chris, right? Ellie's here. Okay. Oh, that's Chris. Good. All right. I have a few people who I don't think are here. If you are here, please say hello. Henrik, Claire, Ryan, James is here. Okay, good. James is here. And Jasmine. Okay. K-Mac. I'm assuming that's also Errol, or is it somebody else? Okay, so anyway, so Felix is not here, I believe. Finton is not here. And Jacob and Konstantin. If these people still show up, please say hello. And I do not know who that is. Okay, Errol does not know who the other K-Mac is. Okay. Interesting. That's interesting. Okay. If you do show up still, the people that I just listed, or you see them, or then please make sure that they still say hi. Oh, here, there's Jacob. Okay, excellent. Nice. Okay, so I have a couple things for you today. First of all, a hello. Hi, Ryan. Hope you're all well, and if you're not well, that you're recovering quickly. And I hope you're all hanging in there with this isolation we're going through. And I hope you're finding ways to fill your day that's constructive. At this point, I'm going to give you a little speech, a speech of encouragement and or admonition. So I think our initial instinct, well, not our, because I'm not including myself in this. Some of you had the initial instinct that Corona-Ferien, and I hope, not I hope, it's not a positive thing, but I'm assuming that maybe by now your thumbs up has maybe moved at least to this position and maybe that position as to that this is not really a good thing. And specifically, Right now, we're slated to have this week and next week off from school, then 2 weeks of vacation, and then we go back to school. That's the plan. However, I think we all have a feeling like maybe this is going to take longer. And I'm not sure. I don't have any inside information. I know nothing more than you do. But I think mentally, it's important for you to have that in mind that, whoa, maybe we're not going back for a while. Maybe we're not going back till August. And if we're not going back till August, that is not a good thing. That is bad because you're missing a lot of education. And I think sometimes it's hard to appreciate that. It's pretty hard to appreciate the importance and the value of school because you guys are kind of used to it. But if you don't have school, yeah, hi, Felix. So if you don't have school, it means you can't learn as much and you can't get smarter and build skill. Hi, Jasmine, and so on. So you need to figure out for yourself how you're going to structure your life for a couple things. First of all, that you can still better yourself and become smarter and know more things. And second of all, how you can deal with the situation for yourself, for your family, maybe for your friends digitally, obviously, and get through the situation as positively as possible. But the priority for me in this little speech is to focus on the academic side and encourage you to still think about that learning aspect, not about checking things off on Google Classroom, although maybe that's okay. I mean, hopefully they're well-designed activities, and then maybe you can still learn. My point is, as you go through the steps, look at actually learning, getting better, getting smarter, not necessarily for grades. Like, for example, quarter 3 grades are not happening. Well, but that doesn't mean that you shouldn't still learn something. Okay. So there we go. That was my little speech. In terms of how we're moving forward with this class, my intention is to do some of these live streams. And I'm assuming we're going to do it about once a week. That's my plan. And unless you guys decide you wanted to do it more often, I don't want to go less because I think it's important to maintain contact and for us to have a feeling like we're still a class, physics class. I'm also assigning things from the book, the Complete Physics book, which is a great book, by the way. I don't know the answer to that question, how the quarter 3 tests are used. And I also don't know, again, the situation is changing by the minutes, hour, day, week. So it's really hard. Hi, Billy. We're in 10th grade here, but you can hang out with us. So we'll figure it out as we go along. That's basically the key to this whole thing. So we have the book, which is a great book. You can learn a lot of stuff from there. I'm going to keep assigning things from there. It's really helpful, and do look through that and do actually do the assignments. Okay. And not just either copy it or copy it off. Solutions aren't hard to find. But anyway, make sure you actually do the work and actually learn this stuff. I will also provide you with some online labs. I'm working on that right now. They're called PHET, P-H-E-T, if you want to take a look. And we'll do an online simulation that you guys can work through. Plus, we're going to do stuff in the live stream. So we're going to kind of mix it up so it's not just like this avalanche of Google Classroom assignments that you just keep working through it alone and feeling very lonely. Okay, so that's the plan for now. What I have planned for the rest of the time, we have about 20 minutes, is to talk to you guys about waves. We have started that subject. We did 3 labs, and those lab reports, many of you turned in several of them and or all of them. If you haven't turned those in, then please make sure you do. I'm not going to look through the list right now, but if you have questions about that, I'll let you know. So we want to talk about waves. And for that purpose, we're going to think about a wave. Finton. Well, hello, Finton. Nice to see you. Okay, I think Konstantin, Claire, and Henrik. Henrik, Konstantin, and Claire are the only ones that are not here. If you are here and you're one of those people, say hello. Okay. So we're going to think about a wave that we're viewing. Okay, we're a strange looking person who has arms coming out of his hips. We're looking out and, ooh, blue. This is so, wow, color. So creative. So we see a wave. Okay, now there's our wave that we're looking at. It's a big wave, okay? And we're looking at it, and we're going to take a picture of it. We take a picture of it, kind of like the one we have here, right? That's a camera, believe it or not. Oh, I'm going to put maybe a little. There we go. So we took a picture of this wave, and we're looking at it. Hi, Jane. Claire, sorry, Jane. Yeah, it's funny. Yeah, hi, Claire. Righty, there we go. So Henrik and Konstantin, only one's missing. So we have this picture, and this person could take a picture and then make a plot, a graph of what they saw. Okay, and their graph would look something like this. So if we defined this level as y equals 0, showing up, it is, then we could make a graph like this, and that person could make a drawing, and it would look something like that. Just showing part of the wave. This is nothing new. You've done this in math. No surprise there. Now, intentionally, I left off the label here on this axis. Okay, on this axis. This is important because they're taking the picture of this, and this is a snapshot in time. It's not changing with time. So this would be a picture that shows this as a function of x. So that would be kind of like, oh, we've got a coordinate system like this. This is y equals 0. This is our y-axis, and then this is our x-axis, like that. Okay, and that's the picture we took. There you go. There we go. And then we transfer this picture over here. It makes sense. Okay, good. Now on this picture, assuming we show this as at maximum amplitude, when it's all the way up and this wave then kind of, we see this thing right there, we could measure certain things off here. Specifically, we could say, okay, well, this height right here, and this is, again, not new, is the amplitude, A. Okay, A is the amplitude. And over here, we could take this distance right here from peak to peak. The peak to peak is lambda, which is a wavelength. So, no, yeah. Okay, so there we go. Yeah, tiny scanner should work out, I hope. If not, then use something different. In an emergency, you can also send a picture, although I really prefer a PDF. It's easier for YouTube because it's a smaller file. Anywho, so this person took the picture, we've made this, we've got lambda as the wavelength of this, and we have the amplitude there in that measurement. Notice the important thing that's missing that you guys might be thinking about, which is period, a period of time. We talked about that in our labs for measuring the time period for how quickly something repeats. This person can't measure that because they took a picture. Now, we're going to have a second person also involved, and we're going to put that person here. So this person is standing in the water. The person is a lot bigger than the other person, and they're having a very large meter stick, and they also have a stopwatch in their other hand. And they might also have a clipboard and a pen and other things to record things. But we're not going to write that down because that's also implied over here that somehow they're recording things. Look kind of like Godzilla. I think that's a good way of looking at it. So this person, ooh, color. Wow, that's pedagogy. Let's see. Does the red one work? Oh, look at that. That's beautiful. So we've got this person now in red and the meter stick. And that's the red person. And the red person is measuring a little bit different than the black stick person over here. Now, this person will measure the height that the wave is making on this meter stick as it passes that person. Okay, so looking at this right now, it's at 0. Then it'll become lower, 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 up, 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 up. Okay, so if that person takes that data and transfers it over onto their graph, they would start at 0, and then it'll become negative, and then it'll become positive. So we look kind of like this. Oopsie, shoot. Okay. All right, let's take a look at that graph that this person did. They again recorded the position Y, and this time they're actually measuring something different. And that can be shown because they've got a stopwatch and they're recording the position on that meter stick as a function of time. So this axis this time is time in seconds. It's a little bit different from what we did previously. Now, again, the height on the meter stick varies from this high to this low. So we again see the same quantity we did there, which was amplitude. We still measure the amplitude. That's cool. A is amplitude. But this time, there's something different going on here because they're not measuring a length in terms of how far it is from peak to peak. Well, what do you mean they're not measuring how far it is? Because this sure looks like a length. Well, it is a length, but it's a length in time, not a length in space. So he's measuring how long the wave is in time, or what the period is until it repeats. That's big T. So that's the period. And he's measuring how long it takes for peaks to pass by. So if the period was 1.2 seconds, the first peak would pass after 1.2, then it would pass after 2.4, then it would pass after 3.6, and so on. Okay, so that would be the basic idea behind the period right there. Okay, so the red person is measuring the period in time, and the black person is measuring the wavelength, which is kind of like the period in space, but not the same thing. Good question, Saskia. So the period is measured in seconds. So just a minute ago, is period in seconds. So it means how long does it take from peak to peak? So how long does it take for each wave to pass the person? Good. So what that means is that's different from the frequency, which is in hertz. Let me just explain. Let's do maybe an easier number. And what I'm going to do is let's do an example and say, let's say the period is 0.5 seconds as an example. So as this person is in the water, the waves pass by now, 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 kind of like that. That's about half a second each. So the periods between the waves coming by is 0.5 seconds. Every 0.5 second, one comes by. That means, well, how many per second pass us? if every 0.5 second one comes by, that means each second, as Errol already typed in, there are two coming through. So let's write that down. T is 0.5. The frequency is 1 divided by that, or in this case, 2 hertz. Jokes about frequency, I avoid them because it hurts. Okay, anyway, so here we go. Frequency is 2 hertz, means 2 per second. A hertz is just an inverse of seconds. Okay, so hertz is just 1 per second, so 2 hertz is 2 per second. Okay, good. So we have an equation here. We can box it if we like and remember it as something that's useful for us to know. There we go. And this is true in general. Frequency is 1 per period, 1 over period. That's frequency. Okay, good. Now, what we haven't discussed here, and this is the important part there, is we haven't talked about speed, the wave speed, because as the wave comes in, the person sees it moving towards them and it approaches them with a certain speed. Now let's see what we've measured. We've measured a frequency of 2 hertz, and let's assume we've measured a wavelength of 3 meters just for fun. Good. And now let's think about what that means. Yes, an idiot triangle with 2 things is not really possible, but what we can do there, we've got this version. I've got some room up here. So we've got frequency is 1 divided by t. It's also true that t is equal to 1 divided by f. So those are the 2 equations for frequency and period and how they're related. That shows up over there? It sure does. Okay, so let's take a look. We have a wavelength of 3 meters, okay? And this wave hits this person in a certain amount of time. Well, how much time does it take this next wave to hit that person? Well, 2 ways of looking at it. You can look at it in terms of period and say, well, it takes 0.5 seconds for the next peak to hit me. Well, I know how speed works. Speed is just distance divided by time. Okay? So for our case, well, that's lambda divided by period. Hi, Konstantin. Thank you for showing up, buddy. Good. Henrik still not here? No. Okay, good. So these lambda divided by t, okay? Now, actually, t is 1 over f, or 1 over t is f, so we can also write this as f times lambda. Does that show up? It sure does. So 2 ways of looking at v is lambda over t, or v is f times lambda. Both those equations are correct. Right? So we can write that up here as our new equation for a little set. V equals f times lambda. And for that, we can make an Idiotendreieck, and we'll draw that over here. So it's V, F, and lambda. And I hope that still shows up. I can see it on my screen. I hope it shows up for you. I will also take an image of the screen, which might have better resolution if you're having trouble reading anything right now. I will upload that. Okay, so V is F times lambda. There's the equation. And we should be able to use this information to now calculate the wave speed. We know the wavelength is 3 meters. We know our frequency is 2 hertz. So for our example, V equals F times lambda. For our example, V is equal to frequency 2 hertz times 3 meters is equal to 6 meters per second. Okay, that shows up okay. There we go. So 6 meters per second. New relationships here for us, at least, important relationships relating frequency and period, and also wave speed, frequency, and wavelength. Okay, and also how we can look at these things in terms of looking at it as a space graph, y versus x, or height versus x, and also how we can look at this in terms of y versus time as a time function graph. That's a common mistake for you guys when you look at these to misinterpret things, what you can read off. So it's important to remember time graphs, you can measure off period, you can't measure wavelength. A space graph, you can measure off wavelength. You cannot measure off period. In both graphs, you can measure off the amplitude. So both those are possible. Okay, this is a super helpful equation, both of these, because they work for us with any kind of waves. Specifically, we're going to talk about the speed of light and the speed of sound, which are super cool things, I think, because they're both fast, but they're still a big difference. There's still a big difference between how fast they are. Speed of sound, just as a reference, because we're going there, is 343 meters per second. That's very fast. So we can use this piece of information together with, for example, the frequency of a sound wave. Well, you might ask, what sound waves are we talking about? Audible sound you can hear, is between about 20 hertz and 20,000 hertz. That's for sound. Okay, so we talk about 20 to 20,000 hertz. And you could use that information to figure out how long those wavelengths are. So I'm speaking to you right now, and I'm probably giving you, my voice is probably a couple hundred hertz in terms of the wavelength frequency. You could figure out what the wavelength is of that. Light, on the other hand, just as a reference, goes with the speed of light. What a surprise. Light travels with the speed of light, and that is 3 times 10 to the 8 meters per second. Okay, 3 times 10 to the 8 meters per second is humongously large. It's 300,000 kilometers per second rather than 343 meters per second, which means it is about 1,000 times, it is about 1,000,000 times faster. Okay, so 1,000,000 times faster than the speed of sound, which is like, whoa. So that's crazy large. That means that light travels at Mach 1,000,000. Okay, just to explain that number to you. And for this number, a good reference for you to have is the wavelengths of visible light. Visible light is 400 to 700 nanometers for its wavelengths. And you could use this range to figure out the frequencies that light has using our relationship. I'm going to get to that later, but I just wanted to kind of give you kind of a where is this useful? How can this be used? And what are we talking about in terms of these waves? Works for other waves too. Seismic waves, slinky waves, any kind of wave. Okay, so that overview, I hope, is a good introduction to waves. My plan is to do about one of these per week, 30 minutes, and I look at the schedule for us. I think this is the better period rather than Tuesday because it's a little bit later. So I think we're going to stick with this as our normal appointment for us to meet online for YouTube. I'm going to still post some things on Google Classroom, and I will also get that PhET simulation that I mentioned earlier for you guys ready, so you can do a virtual lab. I'm not sure what the air quotes were doing there, but it's virtual. Okay, virtual physics lab. And I hope that'll be fun as well, rather than just doing one specific thing. Okay, we do have just a little time. If you guys have any questions, I could answer those. All right, everybody's being shy, I think, maybe. I will record this. I mean, I'm recording, obviously. I will upload this and have it on my channel as, and I will continue doing that, a live stream. You can then later watch as a video if you missed something, if you want to go through it again and try to understand something that you missed. That's totally cool. You can do that, obviously. You can comment on there regarding quality of video, quality of the board, quality of my voice. I'm working here off my computer's webcam, so it's not super high quality, but I hope it's good enough for you to be able to see and follow what I'm doing. Okay? So if you guys don't have any questions, then I'm going to hang up. Are you guys still there even? Somebody say hi. I don't even, you guys are not saying anything. Or bye. Did we get interrupted? Oh, there we go. Okay. Good. Thank you, thank you, thank you, thank you. Good. Okay, good. So glad you guys are still there. Glad you guys were here. Too bad Henrik didn't show up. I'm going a bit too fast. Okay, thanks for the feedback. If you do want to go through it, take a look and do provide feedback on here and or on Google Classroom or email. I'd appreciate it.
Dad, can you give me an extension, please?